In this energy problem, there are two masses, at A and at B. And what happens when there's two masses is you can make two different datums. And I made one for A and one for B. The important thing that you remember, though, is that the datums are at t equals 0 or t1 or wherever your original point is, and that the second part is at t2. You can, if you wanted to, make one datum up here and make a datum total, and what happens with that is you get the total distance from here to here and from here to here. But I like to simplify it and make one height for mass A and make one height for mass B. But you can solve this however you'd like. First, let's solve for the heights. For h of A, you have this total distance of 2 is going to come down here. So we'll have a 0.2, 0.2 minus this distance here, which is the cosine of that 60. So it'll be minus 0.2 cosine of 60. And for HB, it's a little bit longer because you have to calculate this distance first and then this distance. So what you get there is the two lengths added together, which is 0.45. Then you subtract the 0.2 cosine of 60, and you subtract the length from the square root of the side, which is over the square root of 0.25 squared minus the 0.2 sine of 60. So there you have HA and HB. And those equal HA is 0.1 and HB is 0.169722 meters. Once you've calculated those two different datums, then the problem is much simpler and very much similar to what we've seen before, where you have the kinetic energy difference plus the potential energy difference of A plus the potential energy difference of B. Now this kinetic energy difference is of A because velocity of B at 1 is 0 and the velocity of B at 2 is 0. When this is completely stretched out in one long line here, B is changing direction. And from what we've learned from the projectile motion problems is the velocity in the upwards direction is 0. So our VB2 is also equal to 0, and for that reason, we're only looking at the kinetic energy of A. And the mass cancels out, which is really nice, so you get 1/2 mVA squared plus mg, and you get negative h of A and negative h of B, and those are negative because they're traveling downwards. And the mass cancels out, and solving for A, you get square root of 2g HA plus HB. And when you solve for that out, you get that the velocity of A is equal to 2.3 meters per second. So the most complicated part is recognizing that with two masses, you're going to have two different potential energy values, and you need to be able to recognize what is equal to 0.